Hi everyone, this is going to be the video about skew lines and planes. Here we have these two lines, one given by this parametric equation, another is another parametric equation, and they're skewed to each other. And I chose these 2 points from each line, 2, 2, 2, that are the constant terms of these parametric equation, and the other points is formed from the constant term of the other parametric equation. So these are the one easy point you can get out of these two lines. So using Mathematica, it's shown here they are skewed to each other, and with this tool of seeing these two things is kind of not very hard to see how they're lined up, but still thinking about how these two lines are skewed to each other could be tricky if you don't have this type of tool. So how do we orient ourselves and to see this kind of handle these two skew lines nicely? That could be tricky, but the idea is bringing these two planes, these interesting planes that kind of shows you these two some clear pictures of these skew property of two lines. So here it's those two planes, but it is actually motivated by the following problem, which is about computing the shortest distance between these two lines, the skew lines. So I chose these two sample points. So with looking at this red line segment, which forms a certain distance, but that's not definitely the shortest. So what is the shortest? And I'm about to describe the property of the shortest, which is the answer is that this red line segment is supposed to be perpendicular to both the purple line and the blue line if those two a pair of these 2 points form a shortest distance. Because if this point here is not 90 degrees with the blue line, like you see right now, then you can always move it toward to the where that is performing a 90 degree. So then you can make this red segment always shorter than before. So even this one that's definitely not forming a 90 degree, then you can move it toward to, so that it's 90 degree, and then that might have messed up the other points, so you do this adjusting again. So let's not discuss about when this process is going to converge or anything. You can easily argue from this experiment that if there's ever a pair of points that gives the shortest distance, that's the angle is forming with these two lines here and there must be 90 degrees. Otherwise you can always readjust it and make it shorter. So we need to think about the direction of that red line segment, which is perpendicular to both lines, blue and the purple one. So you can easily read off the directional vector of these two lines, and then I sketch them here. So these two red vectors are the directional vectors of a blue line and a purple line, and this black one is supposed to be perpendicular to both these red vectors. Therefore, the cross product will be a good candidate, good choice for a vector that is perpendicular to given red vectors, obviously. Now I need to bring in these two planes like I promised before. So let's think about the plane that has normal vector, this black normal vector, and contains 1 point from this purple line. Maybe it was a P1 or P2, but we chose that 1 point from each line. And think about another plane that has the same normal vector, but it contains a point from this blue line, which could be the other points of P1 or P2. Then let's calculate those. So how to calculate those Cartesian equations is using their common normal vector and dotted with this xyz and minus this point that plane is containing, the standard thing, and here's two Cartesian equations. So when you sketch those down there, and you can see there is this plane that is perpendicular to this normal vector, there's another plane that's perpendicular to normal vector, and they're supposed to contain each point P1 and P2. But as you can see, it actually did more than that. It actually contained the entire line like this and the blue line like that. So it's because the perpendicularity of the normal vector and the two directional vector we created. So from that we have these two Cartesian planes, and from that you can easily compute the distance between the two Cartesian